Hello and welcome back to Steven Data. After learning probability mass function and cumulative distribution function along with mean and variance, it's time to learn the famous probability distributions. So, for the first one, let's get familiar with discrete uniform distribution. The simplest discrete random variable is the one that assumes only a finite number of possible values, each with equal probability. A random variable called x that assumes each of the values x1, x2 up to x sub n with equal probability of 1 over n is frequently of interest. With that being said, discrete uniform distribution can be described like this. A random variable x has a discrete uniform distribution if each of the n values in its range, that is x1, x2, x3 up to x sub n, has equal probability. Then the f of x sub I equals 1 over n. Now suppose that the first digit of a part's serial number is equally likely to be any one of the digits 0 through 9. If one part is selected randomly from a large batch and x is the first digit of the serial number, x has a discrete uniform distribution with a probability of 0.1 for each value in the range of 0, 1, 2, 3 up to 9. That is, the f of x equals 0.1. And for each value in that range, the probability mass function of x is shown in this figure. Now it's time to get familiar with uniform distributions, mean and variance. Suppose that x is a discrete uniform random variable on the consecutive integers a plus 1, a plus 2 up to b, for a is less than or equal to b. The mean or expected value of x is equal to b plus a over 2, and the variance of x is equal to sigma squared, and that is equal to b minus a plus 1 to the power of 2 minus 1 over 12. But before wrapping up the video, let's see an example of the mean and variance of the uniform distribution. Let the random variable x denote the number of 48 voice lines that are used at a particular time. Assume that x is a discrete uniform random variable with a range of 0 to 48. Then the expected value of x is equal to 48 plus 0 over 2, that equals 24, and the standard deviation is equal to the square root of 48 minus 0 plus 1 to the power of 2 minus 1 over 12, and that is equal to 14.14. But give attention to this point. These two formulas are more useful than they might first appear. For example, suppose that the discrete uniform random variable y has the range of 5, 10, 15 up to 30. Obviously, we can see that y equals 5 times x, where x has the range of 1, 2, 3 up to 6. The mean and variance of y can be obtained from the formulas for a linear function of x that was introduced in the mean and variance video to be the expected value of y equals 5 times the expected value of x, and that is equal to 17.5, and the variance of y equals 5 squared times the variance of x, and that is equal to 72.92. Now it's time to wrap up the video by reviewing what we have learned so far. First, we saw the uniform distribution formula, which was equal to the f of x sub I equals 1 over n. Then we saw the mean or expected value of the uniform distribution, which was equal to b plus a over 2, and finally the variance formula of the uniform distribution, which was equal to b minus a plus 1 to the power of 2 minus 1 over 12. And that is done. Congratulations! Now you know what the uniform distribution is and you can solve and model real-world problems with the help of it. And remember, for more information about other distributions, you can check out this playlist. Finally, if you like this video, please hit that like button, and if you are interested in statistics, data science and machine learning, please consider subscribing to this channel. By the way, if you have a question about the fields I mentioned, comment it down in the comment section. And don't forget to share my videos with your interested friends. I hope this video helps you a lot, and until the next video, happy learning!